Okay, so we're going to start by looking at generating fog a little bit. And the idea behind fog, let's see if we can just draw it a little bit up here. Okay, just up here. If we imagine that we have a camera here and it's looking in this direction, then the idea behind fog is basically to say I'm going to set some start fog distance here, start fog, and I'm going to set some end fog distance here, and when something is further away than end fog, it should absolutely disappear into the fog. Its color should instead just be the fog color. If anything is in front of start fog, it will just be its own color. Anything that's in between, and this should be on a pixel by pixel level, anything that's in between will be a mix of the color that's calculated and the color of the fog. So we set some particular fog color, and we set the start fog distance and the end fog distance, and anything that's between those distances will be mixed. So right here we'll have a mix where we have the full color of the object and zero color of the fog. Right here we'll have full color of the fog, zero color of the object. Right between them, a pixel that has that distance will have exactly 50% of the color of the fog and 50% of the color of the object itself. And anywhere in between we'll have some weighted average. So that's the idea.
So you could discard pixels that are too far away to be properly seen anyway?
Yes, you can discard them, or this is a nice way actually to have a closer far plane to begin with, and then just mask it away with the fog. So if you put a far plane that's close, then you can see things clip. You can see the far plane clipping just from the regular clipping algorithm. So rather than discarding pixels in your shader, I'd say if you use fog, just set your far plane to exactly the same distance as your end fog distance, and then the clipping algorithm will do this for you. So then you won't have any pixels that close, they'll be clipped beforehand. So that's a nice way, yes. So I'd say in most cases the far plane would just simply be at the same spot as the end fog. Obviously the near plane can be anywhere, and you want most of your scene to be here in between where your actual object is seen, but the fog will mask this. In some cases you want an effect that starts the fog all the way here and it's just mixing it all the way to the end. In some cases you just want to kind of smooth out the clipping on the far plane. So what we kind of have to decide now is where exactly are we going to implement this. So where would you imagine we'd implement fog?
Since you said third pixel in the fragment shader.
Okay, so yes, probably we're going to do it in the fragment shader. So let's look at our shaders here. We're doing fragment lighting now, so let's look into the fragment shader. Nope, not like this. And the question is, which information do we have to add to the fragment shader, and how can we get these distances? There's a possibility that we might have to define some variables in the Vertex Shader as well, just to get them over to the fragment shader. But let's look at what we have and see if we can use it. So for instance, these are the varying variables that we already have. So what could we possibly use to get this fog distance, this fragment distance? So not this, probably not the normal. The S is a vector to the light. The H is the halfway vector, which you've calculated from the vector to the light and the vector to the camera, but it's really the vector to the camera that we want, right? And we also want a vector to the camera that hasn't been normalized. So I've made some changes obviously along the way to fragment vertex shaders, and right now I'm taking the S vector and I'm normalizing that. I'm making a V vector, which is to the camera, and I'm normalizing that. This was mainly because the specularity was a little bit off in many cases when the lengths of these were very different. Then in some cases you could get specularity on a side that actually shouldn't be lit up. So I fixed that a little. So we have normalized vectors here, and we're looking for a distance, so we can't really use these. So there's something that we need. Okay, so we could actually just send this V vector here as a varying before we normalize it. That's one way. Another thing though that we can do to get this distance, because then the thing is, we could not normalize it. If we take its distance here, then we'd have to send that as a varying, and then we'd get an interpolated distance. And I guess that would be correct. Another thing we can do, if we look at the image again here, or draw a new one or whatever. So let's look at this image for a bit and say, if we look at what's happening in I-coordinates, when we have the camera here in the center, we have our near plane somewhere, and we just have the z-axis here, we have the x-axis here, and the camera is always looking here along the negative z-axis. So the far plane is here, and it's just a straight plane, just like the near plane is a straight plane. So if we actually want the fog distance to kind of coincide with the far plane, is there something very simple that we can use without doing any calculations, without doing any distances? Just a single number that we can pick out of the I-coordinates to use in this case. Can anyone see that? So we have some point here, point P, which we're projecting here. And inside the vertex shader, we go from local coordinates to global coordinates to I-coordinates to clip coordinates that we send out into OpenGL. So at some point we're in global coordinates, where the camera can be anywhere and the thing can be anywhere. And we could take a vector like this between them and say the length of this vector is the true distance. Right? But if we want something that approximates that, and I'm not saying this is wrong, this is a fine way to do it. You can say, I'll take this vector, so take the V vector before we normalize it, take its length and use that number, and that's fine. Use that as fog distance. But I'm going to try something else and say, I'm going to say, this distance here is minus PC, right? It's not always in the same distance. Something here is a little bit further away, but we can get a nice fog effect like that that just masks it right to the far plane. So if we're thinking this as something that kind of hides the far plane clipping, then this is fine. If you really want it to be true fog that has the same kind of distance to where things disappear, if we use this method here, our fog distance is going to look like this, right? So things will disappear along this circular line, right? If we only use minus PZ, things will disappear into this straight line here. Which would we prefer to see? Doesn't really matter. We can actually implement it with one and then just switch to another. So let's start by doing this, because if we just go into I-coordinates here, we're going to need one varying variable. And we can just say varying float, or just distance, v underscore distance. Okay, so we're going to have to put that into our fragment shader as well. In the vertex shader, we need to set this to just something. So let's go ahead here and say v underscore distance equals position dot z minus position dot z. Okay, and we have to make sure we do this here after we send position through the view matrix as well. If we do it here, this will just be some arbitrary number and make no sense where things disappear into the fog. So let's try this. This is the way it's implemented in the fixed pipeline, fixed function OpenGL pipeline. Because no things are really done in global coordinates, because we have the model view matrix. That's the combined model matrix and view matrix. So we always go just straight from local coordinates into I coordinates, do lighting calculations in I coordinates, and take this distance, this fog distance in I coordinates. And in fact, since in the fixed pipeline we do the lighting calculations here as well, we actually do the fog itself per vertex, and then it's just part of the color that's mixed. Anyway, so we're going to do this per pixel in this case, since we're doing the lighting calculation per pixel anyway. So now we have this distance. So we'll just imagine that that's working. So where do we want to use this distance? What more do we need now? So if we just go ahead here and say fog stuff, we have this varying uniform. What uniforms are we going to need? What are we going to need to set in our shader in order for this to work?
The distance to start of fog.
Okay, so float fog start and the distance to the end, fog end. What else? One more thing. Sorry?
Color.
Yeah. So fog color, and let's make those U underscore. Alright. No, that's not. Yeah. Okay, so now we have some fog color, we have some fog start, and we have some fog end. So at which point do we use this? I guess we're just going to do it with the entire thing. Whatever color we end up with specularity and global ambience and everything, once we have an actual color right here, we're going to want to add this. So let's go ahead and let's just remove this. Let's say we could just as well, put a parenthesis around this and just use that there. But I'm gonna make this a little bit clearer here. But for color, I'm not using that anywhere else, am I? No. Equals this. We can call it final object color. So we have the final object color here, and now we somehow need to set this interpolated color between the fog and the final object color. So what do we need to check here? We have some fog start, we have some fog end. I guess we can just say if I guess we have v underscore distance is less than fog start. What do we do in that case? Well, we need to set glfrag color to something. Or yeah, okay, we could also say, well no, this is final object color. Let's just say that, yeah, we set glfrag color here to something inside every one of these. So we're going to do one else if something here, and then we're going to do one else. And in all of these, we're going to set glfrag color. Make sure that there's something in there. Okay, so what's glfrag color going to be here? Okay, final object color. Right, what's the else if here? what's frag color going to be here? Well, we set that color. It's just going to be the fog color because we're blending into the fog color. So we can look at it afterwards. What happens if we have a different fog color and clear color? It's kind of weird, but usually you just clear with the same color as you. Anyway, GL frag color equals u underscore fog color.
If we are going to do this test, wouldn't we put that at the top? Skip all the light calculations?
Okay, yeah, that's true. We'd probably want to say, yeah, if this happens, if v distance is bigger than fog end, then we'd probably put that at the top and then just not do the rest.
And with this simple flat,
yeah,
using C coordinates, we could just as well maybe skip this. So we have
we can even discard it in the Vertex Shader, I guess.
Yeah.
Well, no, I don't know, because maybe you actually don't want to have the far plane and the fog at the same place. You want something to end up in. Depends on what you're thinking with this, but yes, you could actually say put this if at the top, and then put an else around everything inside that, but inside that else we'd have to have this and this. So just to make this nice and clear and have everything in the same place here, I'm gonna keep my fog stuff here. But yes, we could do a little optimization by doing this else at the beginning. But we still have to have this inside here and this inside after we do this. Okay. But now what do we do? What would the code in here look like? What do we need to do now? Now that we know we can't put the full fog color and we can't put the full object color.
Do we have a look function?
I'm not sure we have a lerp function, but we can just write it up. We can just start by saying float t or whatever. Or we can say fog, what would we call it? Fog percentage or fog flyttfall. Ratio. Well, fog ratio. There's another word I'm looking for which I always forget. I'll remember it soon enough and change this. Okay, so what's that going to be then? How far along into the fog are we? How can you calculate this? V underscore distance minus fog start divided by fog end minus fog start. To optimize again, you could somehow calculate a single kind of fog width or something like that in order not to have the shader every time it's called. Calculate this and then just send that in, but this is fine. So the distance minus fog start divided by fog end minus fog start, that's the ratio here. So now what will the fragment color be? Okay, so that would be, or the other way around, right? 1 minus fog ratio times final object color plus fog ratio times fog color. Okay, since we're using alpha here, I'd say if we just end up with a final object color, we want the alpha to obviously use that. I'm wondering if we end up with a fog color, if we should just, we could actually say, if we stick this in here, say u fog color dot alpha. So if we send in 1 there, then it'll be I think at that point I'm wondering if we should still put this in here, because we know it's going to be mixed with the fog color anyway, and anything that's behind it will be more mixed with the fog color, so the blending will end up pretty much the same. Just to make sure the alpha value is there for everything. Okay, so imagine this should work, but we need to do a few more things as always in the shader. So we're going to need this would be fog start location, fog end location, fog color location, and here. So fog start location. Fog start. Here. Fog end. Fog color. And so we need to set we can grab one of these. Just stick it somewhere in the bottom here. Set fog color and fog color location. Is there something that sets just one thing here? Set fog start and set fog end. Fog start location, fog end location. That ought to do it. And then we're going to need to do something, I guess, in our game class. So here, inside game, just do it in create here. So we've already created the shader. Okay. Shader dot set. Okay, what should we try out here? Set fog start at, I don't know, 5. Set fog end at 10. Set fog color to what? Black. Okay, let's try something else. Let's set it to some weird green blue color. Alright. See if this works or crashes. Fog start and fog end undeclared in the shader. Missing the U underscore. There. I think that's okay. Fog start. Yes. You want to show fog start and fog end. Okay. We can see it works pretty weird here on the particle effect, so I'd recommend not using this type of simple fog here since we're mixing all the pixels. However,
It's
because of the alpha. So I'd say if we just always do this, let's say it's important for us to take the alpha of each pixel in order for the blending to work correctly when we're using that. The smoke effect fades out correctly as well. But the reason we still see the things there when they're in the fog is because we have black as our clear the screen color and some other color as our fog color. So the normal thing to do would be to have the same color in both cases. So I'm going to see what happens if we put this weird color as our background color as well. So now everything looks like this, but at least it fades into the same color as we have in the background. Okay, this happens. I'm turning. Why? Yeah, because I'm using just minus PZ here. Because I'm using a value that will give me this line here instead of using a value that will give me this circular line here. So let's see what happens.
Can you go what you changed with the alpha again?
Yeah. So in the fragment shader, I just took out the alpha lines in the ifs and elses, and I said I'm just always going to put the material diffuse alpha here, because that's the alpha of the pixel I'm using now. And that alpha has been calculated from, in the case of the smoke, it's calculated from an alpha texture. It's also calculated from an alpha value of the material. So I'm setting a really low alpha there for everything to mix nicely together. So each pixel has a low alpha. When I said whenever the fog is fully there, I'm just going to set the alpha of the fog instead, a full 1.0 alpha. That meant that as soon as it disappeared into the fog, I just see the entire... I guess it wouldn't have made a difference if I actually had the same fog color and clear color, but it's nice to make sure that everything blends nicely. So we should use, because I'm calculating an alpha using the material alpha and the texture alpha, and I'm mixing that together into this material diffuse A here. We better just use that, whether or not we're in the fog or not. And just trust that as soon as we're... This should really never happen. This should have been clipped by the far plane in this case. Right? Except when we're going to make a change now and say, okay, instead of doing this for v distance, I'm now going to say vec for v equals, I'm going to copy this line here and say vec for v equals just this, and I'm going to say v underscore distance equals length of v, and then I'm going to put the normalize here. So I'm going to normalize it anyway, but I'm just using it full length here to use it for the distance, and then I'm normalizing it to put it in here. Or I could say v divided by the distance in order to not have to calculate the length again. No. Either way, we're hoping that now we have a different v distance. Everything else in the calculations should be the same. So I'm hoping that I go in here, and when I turn, it doesn't change what's being fogged away, because now we have this circular area around us. We have a true distance to the pixel, or true distance to the object that's represented, rather than this approximated distance in one direction. So here, let's run this again. So now we have fog, and that means that we can actually go ahead and optimize a little bit by going into, save everything, by going into the game class where we're making the cameras. Where's the camera? Okay, here we have the cameras and perspective projection with this near plane and this far plane. Now the far plane can be at 10 if we want. And this far plane can be at 10 as well, because we have a fog at 10. So okay, it doesn't really change anything that we see, but what it does change is that now we don't have to render anything that's further away than that. Actually, this fog is a bit ridiculously close here, so I'd say for the top-down camera, which is this one, I'd say let's still have this 100, and where we set the fog, start and end. Okay, let's set this just to black again. Go down here and say, when I'm using this camera, I'm going to set this to 0 and this to 0. When I'm using the other camera, I'm going to just set fog end to 110 and fog start to 100. Whatever, just not worry about this. Or let's set it to 90 and 100. Just to make sure, since we have a far plane at 100. But we're basically setting it far away out so that our top view isn't affected by fog now. So our top view is still our nice map, but this is fading out. So when it fades to black, it looks pretty natural. Or not, maybe black fog doesn't look very natural. Maybe it should be some grayish color. But as soon as it's some other color, then okay, and it's working really nicely on the particle effect as well. Just every single pixel is being faded out into the fog nicely. Okay, any questions on this? Feels pretty normal, natural. It's a nice way. We can obviously just make some proper effect out of this and say, let's actually have it a fairly bright gray color here. Put fog start just right next to us and fog end to a little bit further away, so nothing actually fully disappears. And try to make an actual. Okay, now I have to change the clear color as well to the same color. Let's just take this here and put it down here, like so. And okay, let's just put a clear color of 0 in this case. Yeah. Okay, so why didn't the... No, of course we're not clearing. Of course, so we need to do one more thing. Set GL scissor to the same thing, in this case as well. GL scissor, and then we need to actually call GL clear for the color buffer and depth buffer bit. We don't need to call it here, then we'll call it in like so here before we draw each. Let's see how this looks. But yes, we need the far plane to be further away, so we make sure it doesn't clip. Are we drawing both into the same? Viewport, GL scissor, sorry, gdx.gl enable 20.gl scissor test. Let's just keep that in there. whole time. We'll just might as well enable that here in the display function. Okay, so now we're talking. So now everything is fading into this fog like the whole time. Even when we're close to it, there's a little bit of the fog going on. So we actually feel like there's this grayish white fog on everything that we have. Except on the top-down map here, nothing. Okay, so go ahead and play around with that.